Good morning to all my friends in Malaysia, and let me thank the organizers of the Royal Institution of Surveyors Malaysia, Quantity Surveying Division, and the School of Architecture, Building and Design, Faculty of Innovation and Technology, Taylor's University, and the RISM partnering universities for having invited me to deliver the keynote speech for the RISM International Research Conference 2022. It is a great honor and privilege for me to have been invited to this research conference virtually. My dear researchers, colleagues, paper presenters, invited guests, students, ladies and gentlemen. Once again, good morning to all of you and greetings from Sri Lanka. When I was requested to deliver a keynote speech by the organizers of the RISM Research Conference on the sustainability in built environment towards the fourth industrial revolution, I considered to deliver this keynote speech thinking as a researcher I could come up with some key milestone issues that could be deliberated among the research fraternity. Having commenced my own research on this topic in question, I was truly amazed to see the wide body of knowledge written in the world on these two topics. It is then that I decided to put forward some key statements and issues that has been found in my journey on the topic and put forward a collage of such statements that may be worth noting and discussing as built environment professionals. Let me commence by questioning what is a fourth industrial revolution. According to Klaus Schwab, founder and the executive chairman of the World Economic Forum, I quote, "We stand in the brink of technological revolution that will fundamentally alter the way we live, work, and relate to one another. In its scale, scope, and complexity, the transformation will be unlike anything the humankind has experienced before. We do not yet know just how it will unfold, but one thing is clear. The response to it must be integrated and comprehensive, involving all stakeholders on the global polity, from the public and private sectors, academia, and the civil society. The first industrial revolution used water and steam power to mechanize production. The second revolution used electrical power to create mass production. The third used electronics and information technology to automate production. Now, with the fourth industrial revolution, is building on the third digital revolution that has been occurring since the recent years. Driven by exponential increases in computing power and by the availability of vast amount of data, from software to discovering of new drugs, algorithms used to predict our cultural interest, digital fabrication technologies, meanwhile interacting with the biological world on a daily basis, engineers, designers, and architects combining their computational design, additive manufacturing, materials engineering, and synthetic biology to pioneer symbiosis between microorganisms, our bodies, the products we consume, and even the buildings we inhabit." End quote. As built environment professionals, what is our challenge? One can see that this fourth industrial revolution will effect a fundamental change in the ways that we live and work. It will be a new chapter in human development enabled by the merging of the physical, digital and technological world, and will fashion in technologies in ways that create both promise as well as peril. As digitalization continues to advance rapidly, the pressures on the stakeholders in the architecture, engineering, construction and operation, for short term it's called ACO industry, to revamp and restructure their activities and outputs will become increasingly prevalent. Built environment professionals will have to work with tools such as artificial intelligence for sustainable construction, augmented reality, big data, building information modeling, biomimicry, blockchain, cryptocurrency, cybersecurity, drone gamification, Internet of Things, machine learning, nanotechnology, robotics, and virtual reality. Isn't it mind-boggling? These will be our challenges and as educationists and trainers in both the public and the private sector, our focus should be on upskilling of our young professionals and our students in the built environment if they are to keep up with these new challenges. Another important catchphrase among built environment professionals all over the world is sustainable development, or short SD, which has been emerging as a global strategic vision that should be addressed to meet the economic, social, environmental and technological challenges that we face with the arrival of the fourth industrial revolution, and SD has become important to the world's future. As per United Nations Transforming Our World, the 2030 Agenda for Sustainable Development states that in the second decade of the 21st century, humanity is confronted with the emergence of the fourth industrial revolution, or Industry 4, or IR4, and the demand to implement the 17 Sustainable Development Goals, SDGs, set out in the Agenda 2030 for sustainable development must be adapted in all countries of the world by 2030. The agenda balances and links the three dimensions of sustainable development, mainly economic, social, and environmental initiatives. Various countries and the world regions are adopting the advancement of SD and to see how it will impact innovation. With Sustainable Development SD, several definitions of sustainability have been proposed over time. The World Commission on Environment and Development Declaration reads, "Sustainable development is a process of change in which the exploitation of resources, the directions of investments, the orientations of technological development and institutional change are made consistent with the future as well as the present needs." According to WWMDPI Journal Sustainability 2021 states that sustainability is directed at enhancing human living standards while improving the availability of natural resources and ecosystems for future generations. More than half the global value created today is achieved by less than 1/10 of the global population. Sustainable political, economic and social stability can only be achieved if mankind is able to create worldwide and not only in the first world, but improving the living conditions of human dignity in other regions of the world, and I close quote. As built environment professionals, the impact of the IR4 will be faced with engineering challenges. It will include the design processes and products with improved usefulness and less negative environmental impact. Technology, interpreted as science, will be systematically exploited for useful purposes. Technology will enable processes to transform natural resources into products to meet human needs. The interaction between the researchers and education will impose dynamics as to how creative solutions will be developed for relevant tasks. Due to new means of transport and communication, knowledge and value creation will no longer be limited to niches of wealth, but will be more and more accessible to everyone, everywhere, at any time. These dynamics must be understood and well managed in different regions of the globe, considering the different societal frames with different value systems, in considering the economic, ecological, and socio-political issues in the various parts of the globe. With reference to a book written on sustainable construction in the era of the Fourth Industrial Revolution by SIOD, Emmanuel O'Kay, S. Clinton, and Stefan Wellington, and Didi Buku Tawala, they indicate that when working towards sustainable construction projects, the Fourth Industrial Revolution can bring the technologies that could assist and accelerate construction sustainability. The various digital tools will help in enhancing construction projects sustainability. It will also prove an in-depth insight into the concept of sustainable construction across both developing and the developed countries. It will provide an in-depth insight into concept of sustainable construction across both developing and developed countries for construction professionals like us, sustainability experts, researchers, educators, and other stakeholders. Having discussed about the arrival of Fourth Industrial Revolution, IR4, and its impact on sustainable development, SD, I would like to bring up some examples of how various companies, public institutions, and in various parts of the world has embraced this phenomenon of SD and IR4. For example, Ferrovial and Microsoft already have started the work together on the former Smart Roads project, where Ferrovial and Microsoft have agreed a global alliance to advance the development of sustainable digital solutions for the construction, infrastructure, and mobility industries. The agreement includes the two companies working on the digitalization of ferrovial operations, including processes, automation, frontline worker communications, and project collaboration, and the development of zero trust cyber security models. The agreement also includes a search for new ways of building and providing energy for the optimization of Microsoft data centers and the development of innovative technological initiatives and solutions that enable sustainable development. The pair will also collaborate on the data capture and processing solutions to improve sustainability objectives at the operational and corporate levels. These include the intelligent collection, emission data, and the creation of dynamic reporting on business activities such as carbon and water footprints. Ferrovial and Microsoft already collaborate on this so-called IVIA, AIVIA. This alliance represents a common vision and strategy around the value of digitalization and sustainability being a unique opportunity for co-innovation and development of digital solution to accelerate the digitalization of our infrastructure, as stated by Ignacio Madridigas, CEO of Ferrovial, and further added by Alberto Granados, President of Microsoft Spain, that they share with Ferrovial a strategic commitment to innovation, digitalization, and sustainability, which we want to take to the next level with this alliance. The experience and leadership of both companies will enable them to advance the joint development of sustainable digital solutions to transform the construction, infrastructure, and mobility industries. Another example of digitalization is the creation of new algorithm that automatically identifies architectural elements and creates 3D models of building interiors. Over the last decade, the demand for digital twins has increased. Additionally, point clouds are used to create 3D models with BIM methodologies called ABM Indo. The algorithm works with the organized and unorganized point clouds and provides 3D models of buildings in vector format. This is stated by author Rosis Romero Jaran and Jose Joan Arons Justel. Similarly, Subhaya Aziz, please pardon me for pronunciation of the names incorrectly, states that the 3D city models are used as the underlying base for the smart cities before being combined with other smart technologies such as building sensors, traffic control, street lighting, and other advanced tools. 3D city models are being built using various spatial data acquisition techniques. Nevertheless, it is relatively challenging to acquire complete large-scale environment 3D spatial data using a single type of sensor because of limitations, such as a single perspective view. Thus, the integration of different types of data sets or sensors is necessary. The article explains how 3D point clouds produced from sensors are used as data input and processed using Bentley context capture software while testing the performance capability using various inputs. I must say I am proud that this study has been conducted in 3 cities in your country, Malaysia, which is Putrajaya, Shah Alam and Johor Bahru. So there is digitalization in your country, and I am sure with this conference you are going to go very much forward. Another indicative that has been taken by Global Cement and Concrete Association, GCCA, is undertaking of a collective responsibility for carbon reduction in construction. GCCA states that the concrete carbon footprint is notoriously high. It is currently amounts to 2.6 gigatons of CO2 annually, around 7% of the total global emissions, and is identified by the Global Cement Concrete Association, GCCA, and it says that needs necessity for drastic action. Andrew Vinson, Concrete and Sustainable Construction Director at the GCCA, states that they have a responsibility to change the behavior and lower the emissions. The concrete sector has set out its roadmap to net zero carbon emissions by 2050. He states that there are 3 ways construction professionals can help: use of secondary cementitious materials in clients' briefs, efficiency of design and construction, and wider knowledge on the life cycle carbon analysis. He also states that construction professionals could be doing more to reduce concrete carbon impact in their projects. The other initiative that has been taken is the BMB project, Buildings as Material Banks. The BMB 16 partners of the 8 European countries have been working together with one mission: enabling a systematic shift in the building sector by investigating and creating circular solutions. Today, building materials end up as waste when no longer needed, meanwhile destroying the ecosystems, increasing environmental costs, and creating risks of resource scarcity. To create a sustainable future, the building sector needs to move towards a circular system, a pattern in which buildings and building materials are used, reused, adapted, and rebuilt over and over again. Where an industry goes circular or not depends on the value of the materials within it. Worthless materials are considered as waste, while valuable materials are reused or recycled. Increased value equals less waste, and that is what BAM is creating. Ways to maintain and increase the value of building material. Some contributions are increasing awareness of sustainability and circular economy. BAM will contribute to the enablement of systematic shift where building designs for change can be incorporated into a circular economy. Through design and circular value chains, materials in buildings maintain their value. Instead of being to be waste, buildings will function as banks of valuable materials, building materials and building systems, conserving material value and functionality so materials and building components can be used, and thus decreasing the need for primary resource mining. The BAM project started in September 2015 and have progressed for 3.5 years as an innovation action within the EU-funded Horizon 2020 program. Increasing awareness of sustainability and circular economy, downcycling of construction and demolition waste, landfilling practices are also some benefits. Closely linked to the digitalization trend is building information modeling, BIM, and is considered as one of the most promising innovations in the modern era of architecture, engineering, and construction, or AEC industry. Industrialization has led to many of the world's current economic problems. For example, climate change, unsafe levels of pollution, air pollution, the depletion of fishing stocks, toxins in rivers and soils, overflowing levels of waste and land in the ocean, loss of biodiversity in deforestation can be all traced to industrialization. As the fourth industrial revolution gathers pace, innovations are becoming faster, more efficient, and more widely accessible than before. Technology is also becoming increasingly connected. In particular, we are seeing a merging of digital, physical, and biological realms. New technologies are enabling societal shifts by having an effect on economics, values, identities, and possibilities for future generations. We have a unique opportunity to harness the fourth industrial revolution and the societal shift it triggers to help address environmental issues and redesign and how we manage our shared global environment. The fourth industrial revolution presents also a great promise to leapfrog traditional developments and accelerate the transition to a more sustainable urban future. Fourth industrial revolution, technologies such as artificial intelligence, autonomous vehicles, and drones, the Internet of Things, advanced materials, 3D printing, biotechnology are particularly relevant to our built environment professionals. Cities can harness these pioneering technologies, combined with each other and with new business models to only enhance when urban economic productivity, but to reduce, not only enhance urban economic productivity, but to reduce environmental impact and increase well-being. The fourth industrial revolution, however, also presents its own sets of risks and could also aggravate existing threats to environment security or create entirely new risks that we need to be mindful of. I hope in this keynote I have attempted give you an overview of the fourth industrial revolution, IR4, and its effects on sustainable development. It is our duty as built environment professionals to see how the fourth industrial revolution is changing the environmental sustainability in emerging cities and in the regions, and a shining light of existing and the future opportunities for these cities to harness these innovations for sustainable outcomes. Further, to invest in the enabling technology infrastructure and skills to ensure that our professionals are not left behind, and also to be aware as to how to minimize unintended harmful impacts of the fourth industrial revolution. I have covered a number of issues and issues that can be discussed in this conference, and I'd like to thank every one of you for listening to my speech, and I hope it was worthy, and I hope the conference will be a success, and I would like to say very best to the organizers and their participants, and may you discuss the challenges of IRS and sustainability and deliberate in length and be made available to conference participants for the future generation of our professionals and our students. Thank you very much.